So hello everyone, in this session we are going to discuss about a case study on technology scaling. What is meant by scaling technology or technology scaling here in VLSI? Normally we have an IC, right? So the IC consists of n number of transistors in it, right? So whenever we are upgrading the technology, the number of transistors will goes on increasing, right? So automatically what happens to the size of the transistor in the ICs? It will be decreasing. So this one we will be calling it as technology scaling. Okay, so we have some many advantages as well as disadvantages in it. So we are going to take a particular case about, for example, the transistor size in an IC is of 90 nanometer, and now we are upgrading it to 40 nanometers. So what are the things happening here we are going to discuss in this session. So initially, normally we have a 90 nanometer transistor in an IC, and it has n number of transistors embedded in an ICs. Okay. So what are the advantages of having a 90 nanometer transistor? Yes, please.
It has high manufacturing yield and it is stable and well characterized model. It has lower development risk, and it is suitable for both embedded and electrical
applications. Good. So these are the advantages of using normally a 90 nanometer size transistor. But we can go for the smaller size as well. So what are the limitations of having a 90 nanometer size transistor when compared to the 40 nanometer transistor? Yes, ma'am.
The limitations are larger chip area and limitation transistor density and higher dynamic power compared to advanced mode, lower maximum operating frequency.
Okay, thank you. Sit down. So whenever we are going for the lower size, right, the density will be higher. Okay, so where will be embed n number of transistor in it, so the density will be higher. And the next one is the operation, right? It will be very quick and the efficiency will be very quick. So that is one of the advantage, and power consumption will be less in it. And now we'll have a discussion about what are the purpose of going for this. Yes. Regarding power consumption.
For higher performance, reducing channel length, it improves transport and reduce gate delay. Shorter gate length increase higher performance.
Thank you, Masira. For example, the point we have explained, right? The transistor of higher size, and we can just take a transistor of lower size. The transistor with, for example, of 90 mm, right? It has higher gate channel length when compared to the channel length of 40 nanometer, right? And the gate length is less when compared to the previous one. So the current will be moving very quickly in the lower sized transistor because the channel length is very less. So this is one point. So the the gate delay will be very less and it will be very quicker to perform. So that's the point we have said. Yes.
Scaling from 90 nanometer to 40 nanometer, it has double transistors, and it has smaller die size, and it products more production and high volume, and
okay, thank you. So we just explained about the chip size, how it will be embedded in it. Now we have a small glimpse about the power consumption between these two sizes. Yes.
Comparison of total power consumption of 90 nanometer and 45 nanometer. At the 90 nanometer, dynamic power dominates and leakage power is rapidly small. And at 40 nanometer, dynamic power is reduces due to voltage scaling, and leakage power is increases significantly. Leakage becomes a major design concept, and especially for battery powered microphone.
Okay, thank you, sir. So now we have discussed about the advantage, disadvantage, and with the help of power consumption and all, right? So what are the points you have understood? Normally, when we have n number of transistors, we have short channel length, and number of transistors will be in billions and trillions, and it goes on, right? The power will be, we'll have an efficient one. And what is the other point we have discussed? The chip's area size will be very less. A particular transistor size will be very less when we are increasing the number. And what are the other points we have discussed? Efficient one next. Okay, so these are the points which we can summarize in overall thing. Okay, so in upcoming technology also, whenever we are upgrading a IC, the billions and the transistor number, right, it will be getting increased. And this is one of the effects we have already discussed. Okay, non-ideal ID effects we have discussed. So this is one point, right? Long channel effect. So this comes under that. So we'll conclude this session. Thank you. Yes.